this if you have problem, or you can come to office hours. So there's something I want to show you. We started with first order ODE. And for this first order, we talked about separable. Who can remind me the general form of separable differential equations? If you check your notes, what's the general form? Anyone? Yes?
mx dx plus ny
M a function of x dx, yes, plus
ny dy.
any function of y dy is 0, right? And separable you could solve by direct integration, first order. Then we move to integrating factor method. So for integrating factor, how do you solve that? Anyone? What's the formula for integrating factor? Who wants to try? Yes, Sean.
mu is equal to e to the power of
Integrating factor is equals to, yep,
to the exponent of
exponential,
the integral of p of the power to p to the x.
like this.
Yeah.
So what's the general form? Let's start with the general form. What is the general form for integrating factor? Yes.
Y prime
Y prime. Yep.
plus P of X
P of x, yes.
Y
Y, like this,
equals Q of X.
equals Q of x, like this, right? Is this correct? Okay, so you find the integrating factor using this method and we derived it, right? And what will be the solution? Y? What will be the solution using integrating factor? Anyone? Yes.
Y is equal to the integral of
Let's start with y multiplied by integrating factor, right? Will be integral
q of x
q of x.
times u of x times the integrating.
What's q of x?
The q of x.
This one.
Yeah.
Then multiply by what?
The integrating factor.
Multiply by integrating factor dx, or mu of x, anyhow you want to call it. Why am I reminding you this? Because after today we're leaving first order, we're going to second order. It's good to remind ourselves what we've covered there. Then after integrating factor, we talked about the exact. What makes a differential equation exact? Anyone? Yes.
So two functions of x and y.
Two functions of x and y. So how do you write it if you want to follow this form? How do you write it?
So mxy
M a function of x and y. Yeah.
dy
Dx or dy. Dx plus n a function of x and y. Yeah. Dy is 0. So what condition makes this exact then? If this is the general, yeah.
if both the partial derivatives are equal to each other.
The m, is that what you're saying?
Yeah.
The m d what?
The
Dy
y. Yeah.
equals the n dx. Does that make sense? And what will be the solution? If f a function of x and y, if f a function of x and y is c is the solution, on what conditions do you use this solution? Who remembers? Or how do you solve exact? Let's put it that way. Who can give us the 3 steps to solving exact differential equations? Yes.
You take the partial derivative
Df,
df
yeah,
dx.
df dx equals to this function, right?
Yeah.
Then you integrate it to find f, right?
Yeah.
Then you have d a function of y, and then you do df dy to find that. Follow those 3 steps. How about if the m dy is not equals to the n dx? What do we do? Yes, Sabrina.
Multiplied by
Integrating factor. Yes, it means it's non-exact. Non-exact. We can make this exact by multiplying by integrating factor. You're free to check your note. This class, we derived all this formula. We did not memorize. So how do you find the integrating factor? There are 2 types of integrating factor. Integrating factor could be a function of x. It could be a function of y. You can check your notes. We derived both also last week. Who wants to tell us? If integrating factor is a function of x, what is it? Anyone? Yes, Fee.
E to the power of the integral dm.
Like this?
Yeah.
Yeah.
dm dy
dm dy
minus dn dx
minus dn dx
over n
over n, yeah.
with respect to dx.
And this one will be what? E, complete this one then.
dn dx minus dm
dn dx minus dm dy, right?
Yeah,
over
over
n. Or dy. You can check. When do you use this and when do you use this? This is the one that created the problem in the homework. When do you use either of them? And I gave you a one-page write-up to explain when you use them. Does anyone know? Yes?
It's like when you can get it in terms of just one variable.
Yeah. So when you evaluate this function here, like all here, when you evaluate it, and then you end up with a term that has just x, right? So this you use. If you evaluate it and you end up with a term that has just y, you use this. But if you evaluate it and you have a term that has both x and y, that is more complicated, like the one we did in the homework. And we said we did not cover it. It's outside the scope of this class. But in our lab, I'll show you how to solve that in Python, which is this Wednesday, right? So most of the questions you will get are when is a function of x and y. You won't get the x and y, like the homework one. You will not get that. Okay, so that's all we will cover for the context of chemical engineers about first order. X plus ny dy is 0. What kind of differential equation is this? What kind of differential equation is this? Yes? Separable. Can you show that a separable differential equation is also an exact differential equation? Can you show that? Who can show that a separable differential equation is also an exact differential equation? If I give you a question and say, prove that a separable differential equation in this form is the same as an exact differential equation. Yes?
dm dy
Great.
would be 0 and
Yeah.
so would dn dx.
That's correct. So if you do this, our exact is this condition here. So to prove that a separable is also exact, if you do the m here, if you do the y, is 0 because there is no y here. Right? And then if you do the n, the x is also 0. So you can see here that a separable at some point is exact. That's great. Okay, so we're leaving first order, we're going to second order differential equations. Before we move to second order, any question? Any question? Who can tell me what a second order differential equation is? Remember, we talked about order of a differential equation. What's a second order? Anyone? Yes?
Power derivative is 2.
Yeah, power is 2. Second order is power is to 10. So we can have a second order as, say, the square y over the x squared plus dy dx. Let's say we can have p of x the square y plus q of x dy dx plus c of xy is, say, w of x. This could be a second order. It's second order because the highest power here is 2. Now, for the context of this class also, there are 2 types of second order we would look at. The first one is homogeneous and non-homogeneous second order. Does anyone know the difference between the two? Assuming you have a second order written in this form, does anyone know the difference between homogeneous and non-homogeneous? Anyone?
Homogeneous mean equation with the same variable.
You're close. Okay, so if this guy here is equals to 0, we call it homogeneous. And that's what we're going to solve this week. Next week we'll do the non-homogeneous. There are several ways to solve that also, which we'll talk about. If this guy is not equals to 0, we call it non-homogeneous. Fee, can you see?
Yeah.
Amy, you can see? Okay, great if you can see that. But before we go into solving this, if you look at your workbook here, I put a reminder difference between linear and non-linear, page 1. So I would ask you to tell me the answer. The reason is because we're dealing with second order linear differential equations this week. So I wanted to remind you what we covered week 1, difference between linear and non-linear. So you tell me, number 1, is it linear or non-linear? Number 1. The first page, page 1 of your workbook. Linear or non-linear? Anyone?
Linear.
Linear. Y is exponential Rx. Let's assume this is our solution. Okay. So let's rewrite the differential equation again, which is P of x d square y over dx squared plus, what do we have there? We have Q of x dy dx plus C of xy is 0. We put 0 here because we're dealing with homogeneous, right? This one. So we assume this is our solution. The other thing is, let's replace this with numbers so it becomes easier to solve. We could say, let P of x be A, Q of x be B, and C of x C. Let's just replace it like that to become easier. So our differential equations becomes A d square y over dx squared plus B dy dx plus C y is 0. So we already say assume our solution is this. So what will be y prime? If y is this, what is going to be y prime? Someone. If y is exponential Rx, what's y prime? Anyone? Yes?
R exponential RS.
Thank you. I know most of you know it, you just don't want to talk. You could just give me a sign with your eye, it's fine. I would understand. What is y prime prime? Yes. Remember, there is no wrong answer in this class. Okay. Yes, go ahead. Tell me. Anyone? Yes, Nina.
R squared equals Rx.
Okay, R square E Rx. I'll start giving out bonus points now if you answer question. Okay. Okay, let's put them together. So let's replace everything here. If we replace it here, it becomes A, instead of this guy, you know this is y prime prime, right? Becomes A multiplied by R square E Rx plus, instead of this, it becomes B R E Rx plus, instead of this, it becomes C, instead of this, Y becomes E Rx is 0. Okay, so this is common in 3 of them, so we can bring it out. It becomes ERX like this, right? So we could, since if you divide through by this, it becomes like this: AR squared plus BR plus C equals to 0. What kind of equation is this? Yes, quadratic equation. And for quadratic equation with this form, the general solution is minus b, right? Plus or minus, you all have done this several times. Root b squared minus 4ac divided by 2a. That's the solution for R. Is that correct? I remember because we do it every time in chemical engineering, right? Material and energy balance. So that's why I'm able to remember too. Remember, the reason why you are learning this thing is not just to know how to solve it, but to know how to apply it in what problems, which we're going to do shortly. This solution here can have 3 forms. So I can call it 3 case study. Let's call it the case study. Or case studies, whatever. So your b squared can be greater than 4ac. Your b squared could be equals to 4ac and b squared could be less than 4ac. Let me take you back. So when b squared is greater than 4ac, what would the root be? What kind of root would you have when b squared is greater than 4ac? Anyone?
Positive number.
Yeah. Two real roots. Is that what you said? Yes. So you have two real roots, which is R1 and R2. That's what you have. You have two real roots, or two real solution, whatever. So your solution would be y would be c1 exponential r1x plus c2 exponential r2x. Given r1 and r2 are the roots for this case study. That will be your solution to the differential equation. C1 exponential r1x plus C2 exponential r2. This is r2. How about if b squared is equals to 4ac? Yes?
Can I ask a question about that?
Yeah.
What's the difference between C1 and C2?
They are constant.
What's the difference between them?
They are two different arbitrary constants. Right? And I'll tell you how this came from. This is how it came from. Although we'll talk about that when we get to principle of superposition. These roots are R1 and R2. They're the two roots, right? So that means the solution is supposed to be y would be C1 exponential R1x, and you also have y is C2 exponential R2x. These two are constant related to each individual solution. And then, if you have a second order differential equation with two solutions like that, you could say the overall solution would be C1 exponential R1x plus C2 exponential R2x. Of course, we will have a question where we will be required to solve for C1 and C2. There's a question we'll solve that, I think example 3 or example 4. So, if b squared is equals to 4ac, that's a good question anyway. What would be this? What kind of root do you have here? Do you have one answer, two answers, or what do you have? Anyone? Yes? You're raising up your hand. 0? 0? Is that what you mean? Any other person wants to? Mora, I thought you were raising up your hand.
No, I wasn't, but wouldn't it just be only one real solution, which is
Yeah. You would have just one answer, right? And then, since you have just one answer, you could call it R. Just one. So the solution y becomes C1 plus C2x exponential Rx. Just so you know, we'll derive this also. I'll be able to derive this for you later on. So how about this? If b squared is less than 4ac, what kind of solution do you have? If you look at it here, if this b squared is less than 4ac, from here, what kind of solution do you have? Anyone? Yes? Yeah, you also call it complex. You're right. It's complex root because this will be negative. This term here is going to be negative, right? Since it's negative, you would have a complex root. So we could call it alpha plus or minus beta I, where I is root -1. That's what you have. Right. So our solution would be y is exponential alpha x c1 cos beta x plus c2 sin beta x. Second order is actually much more easier than you would imagine. Let's solve a few questions, then we'll go back to how to derive these formulas. We'll derive them too. Let's go to the workbook. So, the short way to solve it is, you know it's homogeneous, this is 0. You know it's second order, right? So what we want to do is, this here is, you assume it's r squared minus, this becomes 5r, then this plus 6 is 0. let me take you a step backward to show you how I assume this. Remember, we always say assume our solution is y is exponential rx. Our y prime is r exponential rx. Our y prime prime is r square exponential rx, right? So if you take this and you put here, it becomes r square exponential rx minus 5 r exponential rx plus 6 exponential rx is 0. If you factorize exponential r square out, it becomes exponential rx r square minus 5r plus 6 is 0. So that's how we arrive at this. This is how we arrived at this. Right? Okay, I'm going to take a break and let you see if you have questions before we continue. Question. Sean, can you see from there? Can you see what I wrote here?
Yeah.
No? Yes?
On the exam, we can just jump straight to the R squared.
That's 25. Do you agree with me? Your 4ac is 4 times 1. A is the coefficient of r squared, which is 1. And your c is 6. That's 24. So here, our b squared is greater than 4ac. So that means we're going to have two different roots for this. So case 1, our solution would be in this form. We just need to find what r1 is and what r2 is. So in that case, if you have r squared minus 5r plus 6 is 0, this is a quadratic equation. You could solve it using any method. Factorization method, any method you want to use, right? So when you solve this, let's use factorization method. So this becomes r squared minus 3r minus 2r plus 6 is 0. Is that correct? This is with the assumption that everyone here can solve quadratic equation, which is true. So this becomes r minus 3 minus 2 r minus 3. So our answer becomes 2 and 3. Is that what you got to? So our solution y becomes c1 exponential 2x plus c2 exponential 3x. This is the solution. Isn't that straightforward? I'll let you do question 2. You can try question 2 and tell me your answer. Like you said, you could jump steps. It's allowed here. So you could just say this is r squared minus 6r, right? Plus 9 is 0. Is that what you did? Did I miss anything? So b squared is 36. So b squared is 36. Then 4ac is 1 times 4 times 9, which is 36. So our b squared is 4ac. So we are left, our solution will be in this form. We just need to look for the r, which we'll get by solving this. And when you solve this, you will get r as 3. If you solve it, you will get r as 3 when you solve it. So our solution y becomes c1 plus c2x exponential 3x. c1 and c2 are constants. Yeah. Question 3. Anyone has done question 3? Yes. This is what we have. Okay. This is tricky. If you have any answer that's c2e to the x, like this? Yeah. Okay. That's interesting. Anyone got? Is that what you did? So how do we solve this? Someone help me out here. How do we solve this? Yes?
Right, so I use like a method where you draw like an X, and then you put in the top, you put the constant, which is 0 times, what is multiplied by r squared.
Yeah.
And in the bottom, you put the number that is multiplied by r, which is -1. And then you could do like 2 numbers on the side that they have to multiply to the top and then add to the bottom.
Okay. So you went the other way. It doesn't mean you're wrong. Yes? Sorry. I did not mean that, right? Trust me, I did not mean to throw the back at you. Go ahead. Yes, like this. Is that what you meant? Okay. So this can be R is 0 or R is 1. Anyone else got this as the answer? Okay. Then it means you have two answers you can put in there. That's why exponential 0 is 1. That's why you have C1 plus C2 exponential x. Now, let's go to why we're chemical engineers. Flip to the back.
C1 cosine 6x
Plus
C2
C2
sine
sine 6x. That's question 1 on page 5, right? Is that the one? Square x over dt square plus c dx dt plus kx is 0. By the way, when you talk about a fluidized bed, yes, Mora.
Can you go through how you got like those two coefficients for beta?
Say that again.
Can you go through how you got like 6 as your coefficient like for beta for the solution?
6.
Like, can you go through how you got that?
Which one? Which question?
The one we just did.
You mean minus 5 dy dx plus 6y is 0. Is it the question you're talking about, Mora?
Yes.
Okay. So, here, remember, if we want to do this question, when we're deriving the formula, we assume our y is exponential rx, right? That's what we assume. So, if you assume that everything here, d squared y over dx squared will be r squared exponential rx, we derive this. Then minus 5 r exponential rx plus 6 exponential rx is 0. Do you get how we got here? So this would always cancel out because exponential. If you divide through, this will be 0 here. So we'll be left with r squared minus 5r plus 6 is 0. This is a quadratic equation. And we solve the quadratic equation. If you have you can do it and tell me who has done that. Yes? 4? Are you sure? 4. What is this one? That would be 200 divided by 5. That's 40. Is that correct? Okay, 40 is 0. Okay, let me take you a little bit step backward. What type of differential equation is this? Tell me everything you know about this differential equation. Everything. Number 1, second order. Number 2, linear. Number 3, ordinary. Number 4, you're missing one. Homogeneous, because this guy is 0. So if it fulfills those 4 conditions, we can solve it using that method. Then you can say the one that has prime is the r squared. You can, of course, say y is exponential rx and do everything. It's allowed. Plus this one is 4r. Then plus this is, am I missing something? Yes, this x is missing here. You should told me I missed x here, right? Is that correct? That's supposed to be y, not x. Because if you see, this is the x dt. So it's correct. So x is the independent variable, t is the dependent variable. Let's put it, yeah, it's plus 4x is 0. It's still correct.
It's 40x.
Thank you. Let's put 40. Yeah. Plus 40. Yes, right? That's correct. It's 40. Okay, great. If you feel I make mistake, tell me now. So b squared is 16. 4ac is 4 times 1 times 40, that's 160. So b squared is less than 4ac. For sure, b squared is less than 4ac. So if that's the case, we know that our solution y will be exponential alpha x This time our x is t, alpha t. C1 cos beta t plus C2 sin beta t. Please cross-check this if this is correct or not. You can check your notes. So let's solve this. So to solve this, we say our solution R would be minus b, which is minus 4, plus or minus square root of b squared, which is 4 squared, 16, minus 4ac, which is 160, divided by 2a, 2 times 1. So that becomes minus 4 plus or minus square root of, what is 16 minus 160? Anyone, 16 minus 160? Please help me out. 120, what's that? 126, right? No, it's 126. No, 140, 141, 144.
Yes.
144, thank you. Okay, so minus 4, this could be same thing as square root of 144 multiplied by square root of minus 1. Do you agree with me? Yes, we could do it like that, divided by 2. That would be minus 4 plus or minus, what's square root of 144? 12. What's square root of minus 1? I. So that would be 12i over 2. That would be the same thing as minus 4 over 2 plus or minus 12i over 2. Right? That would be minus 2 plus or minus, right? Now I'm confused. Is this correct? Minus 2 plus minus. Okay, remember the condition is if you have your solution, say R is alpha plus or minus beta I. That's the condition. So what that tells you is that here, our alpha is negative 2, and our beta is 6. Is that what it tells us? So let's plug in, if you look at this, alpha is negative 2, beta is 6. So let's put it here. So if we put it here, it becomes our solution x. X is our solution because x is the independent variable. Don't get confused. It's x and t, not y and x this time. So x would be exponential minus 2t. C1 cos beta is 6t plus, let me take this here. C2 sin 60. Okay, Paige, do you have a question now? Great. Let's go a little bit further. Do we have time? We have time. So every 2y is 0, y of 0 is 1. Okay, if you've done this, tell me the answer.
Exponential negative 2x plus c2 dx.
Did everyone get this? Okay, particular solution. You need to find C1 and C2. Right? If you have an answer, let me know. Do you have an answer? Easy driveway and must accelerate quickly uphill to exit safely. However, there is an oncoming road where cars pass at random intervals, and that is true. If a car is approaching while you attempt to leave, you risk a collision. You want to predict the probability of a car passing at different times of the day based on past traffic data. The traffic follows a wave-like pattern with peak time during morning rush hour 7 to 9 a.m. and evening rush hour 5 to 7 p.m. To model the traffic flow, the number of car passing per minute follows a damped harmonic equation, and I gave you the equation. You have k and omega, whatever that is, and you're given initial conditions. So you have to find the function nt. You solve for nt as a function. Then you predict at what times traffic is lowest. So you have the safest chance to exit, and you plot nt over 24-hour period. I'll let you try this. But I'll give you one hint. You can see a question like this in your test next week. It's really very easy. We'll solve it together, but I'll let you try first. If you have problem or you don't know how to start, put up your hands. I'll come to you. This is all you need. Right? You start by putting these two values here. Then you solve this. Once you solve it to get the general solution, these are the initial conditions. With these initial conditions, you get a particular solution. Your particular solution, your n will be a function of t. With that, you can do 1 hour over 24 hours. You can plot t from 1 to 24. You plot the graph. And then based on that, you can predict, say it's 9 a.m., what will be the number of cars passing? You can do that also. But first, you have to solve this second order first. If you have a general solution, let me know. Anyone?